Hi, it's dumpster room parts salvage time again. As I often find down in the dumpster room, the corporate office tower dumpster gives up fantastic things like this, which is a real, like a big beefy corporate office full color printer. In this case, it's a Dell 5130 CDN for those playing along at home, and it's a huge beast. It weighs, I don't know, 30 kilos or something. It's absolutely enormous. One of these like really reliable high-end office printers. I don't know about this particular model, but anyway, these wouldn't have been cheap to buy, and yes, it does actually work, but there's lines on the page, and yes, I could probably spend like hundreds of dollars buying new drums for it and things like that, but I've already got a color printer. I don't need a big, power-hungry, huge beast like this taking up room in the lab, especially when I'm downsizing the lab. You could sell something like this, but you can't post it because it's ridiculous, so you'd have to, like, I'd have to sell it on Gumtree or something like that really cheap, or just give it away or something. I couldn't be bothered, so let's tear this thing down and see what usable parts that we can get for our junk bin inside a big full color laser printer like this. Now, I'll link it down below and at the end if you haven't seen it, where I've done a photocopier, and I had the same black mat because this is going to get messy. Toner's just going to go everywhere. I'm going to be covered in it, but I don't think I've ever done a full color, you know, big high-end office laser printer like this. We'll see how many usable parts we can get out of it. Before we go, I'll just show you what we've got here. It's one of these full color jobbies. It's got the 4 toner cartridges. Like, how do you get these things out? Anyway, it's got the 4 different color toner cartridges. It's got the 4 different color drums in there. So likely the lines that we're getting on the page have to do with the drums, but it's all messy. There's all, you probably see inside there, there's all toner. It's just a real mess. And this is the toner dump tray and stuff like that. So it's, you know, it's had a fair bit of use, this poor thing. So I don't really want to press this back into action. I'm not sure how old it is, but anyway, so it does actually have the Ethernets on there. It's got an old school Centronics as well, and there's the details for those playing along at home. So let's tear this beast down, see what's what. And there we go. That power supply is massive. Check that out. Wow, takes up the full height. That's worth the price of admission on its own. Ta-da! That's nice. Just comes out as one big assembly. These clips are annoying. That's the main processor. Check it out. Looks like there's a tamper protection micro switch on there for taking out the back processor board. That's interesting. I'm pretty impressed with the wiring inside this thing. You can tell they've put a lot of effort into the design and the construction of this. All the cable looms, look at that. Fantastic there, but this is the mechanical linkage through to this is the power switch button on the front panel, and that goes all the way back through the chassis. You can see the rod down there, hopefully. Spared no expense.
Really spectacular, spared no expense.
I am impressed how this all fits together. Huge amount of mechanical engineering design's gone into this. It's absolutely phenomenal. Well, I tell you what, I'd hate to be the poor bastard who's got to swap this board. Maybe these things aren't designed to be repaired. I don't know, if you're aware, would somebody from Dell, would your Dell man come around in his Dell shirt and fix your printer for you? I don't know. Do they have a company song like IBM?
We'll do 1 verse and 2 choruses of Ever Onward on page 5 of the songbook.
Like a gem, we fought our way through and new fields were sure to conquer with the ever onward IBM.
These things are bloody cable tied. Unbelievable. Tell you what though, this is rather satisfying. I'd be a bit more careful with this if I was had to put it back together, of course. Alright, I think our power supply is going to come out now. It's got a hingy thing at the top. Yep, Bob's your uncle. Look at that. Nice magnetics down there. Wow, I'll have a good look at those later, but It's a gold mine, that power supply. And here's the problem with these machines. I mean, look at the toner just gathering in there. Look at that. Wow. Stuff just gets everywhere. I mean, they can't 100% seal these things, so there's nothing you can really do. Not sure these are motors in here. I think they're all interlocking cogs for all the 4 drums. That's what drives the 4 drums in there. Neat. So it synchronizes them all up, of course. And there we go. If I spin that sucker, it's a reduction gear thing. Sorry if I'm getting my mechanicals incorrect. I'm not sure if they're all the same or whether or not there's some sort of slight synchronous difference, but woohoo! With a bobblehead, wouldn't be good for anything else. Don't know if the motor would be any good. There's your motor driver. And we start getting into the weirdo stuff like this. I'll show you those up close later. So we start getting in, we've got 4 motors up here, 5, and still got another mongrel down there which refuses to come out. Yeah, you can strip out most of the good stuff from the back here, which is really quite nice. And here's where we start getting into the paper feed, the output paper feed. There's our motor in there. Oh, that's just gorgeous. Oh, just the feel on that, the weight. Oh, I wish this was Feel-O-Vision. And the deeper and deeper into this you get, the more impressed you get with all the gears and cogs and everything. That somehow went, yeah, that went in there like that. So that's all part of the paper feed mechanism. I mean, there would have been like whole teams just working on like the output paper path team or something like that. Yeah, it's just incredible. I'm always blown away by the design complexity of products, mechanical products like this. It's absolutely amazing. Now, yeah, that cog's not coming out without a fight. There we go. Look at that. This is the complexity that goes into that, right? And then these things, do these move and engage? Like a lot of it's built from the back, so there's got all your drives. It looks like they're all on this outer surface out here, which is absolutely fantastic. And then they slot in and the gears slot in. Can't even comprehend the man hours that goes into something like this. It's just absolutely amazing. The weight in that is phenomenal. No surprises for finding that the motors up the top here for the drums, they go down into here, which we also got that synchronized mechanism. So they're all driven from the same place, probably sensors, because they're all aligned, they're all synchronized and everything else as the paper travels through the paper path in there. So that looks like, that's our locking bar, I think, on the front. But even that, like, it's just amazing amount of engineering's just gone into that, right? All right, check this out. Watch what happens when I lift up this. This is the drum lock-in. Can you spot what's happening there? These little alignment pins, look, all locking pins, so to speak, 2 of them on each of those drums. Isn't that awesome? Huge attention to detail. Stuff like that, absolutely amazing. And of course, how all these feeders come out, I mean, it's just absolutely incredible. Look at this. And just imagine how many molds would, like, and it can, and please, anyone, any mechanical engineer can guesstimate how many molds would go into something like this. Plastic molds, just absolutely amazing. Anyway, there's our roller. It does nothing else but roll. By pulling this out, this then interlocks. That then allows you to pull out this tray, which is maybe, probably should have done that at the start. Screwed the pooch. Really come a gutser there. Come on, there we go. So that's our paper path tray there. Gets sucked along that. That's just a continuous strip. And lots of excess toner on there. Like, there's lots of, like, there's just excess toner everywhere in this thing. There's no avoiding it. Oh, isn't that a pretty splash of colour? Look at that. And then you get, like, little sensors in there doing something or other. I don't know. And you'll just hear me say it again and again. The complexity that goes into all this is just insane. Look at that. That whole big, you know, imagine having to design all this. Look at this mold. There you go, for those mold aficionados there. UC Hangzhou Ji Zhang ABS. Now I might have this a bit arse about, but you can see down here, this is the bottom tray. That's where our drums go in. You can see the contacts over here for our drums. And these cogs look like they're part of the drum drive there. Now, if you're wondering how the toner gets onto the drum, here's our toner cartridge, okay? This is the part where the toner comes out. You can see that there's a thing that rotates in there. So there's a motor at the back, which I'm not sure like how it and in what quantity it dispenses it, how it dispenses. Obviously, like it lasts a long time, so we're talking about a tiny amount. Anyway, this is the carrier that is bolted into the machine, and you can see that when you slide in the toner cartridge, this matches up with this port down here like this, okay? So you slide it in, it matches up. It's got a little sensor there to detect how much toner, how much Corona you got left, and then it goes down here into this little pipe down here, and then there's another little drive down here which then shoots it out here somehow. But anyway, this matches up with, here's our drum, that mates up with that, so it squirts it into there somehow, but right across. But of course, the idea with the drum is that it is electrostatically charged with the Corona wires and like high voltage, and then the toner powder actually gets electrostatically clings that, and when the drum rotates and the paper passes over it, that transfers the image onto the paper, and then of course the paper goes over the fuser, which then heats up and bakes the toner powder onto the paper. There you go, there's a little port, yeah, it goes down into there, and there's a channel all the way along the bottom there, so that's how it disperses it. And here's Sagan. He's never seen inside a laser printer before. We want your reaction, Sagan, okay? Reaction time! This is all inside a laser printer. How cool is that?
OMG. Look at all the wires in the back. And look at all the big ramp where it's closed up.
The big ramp?
Yeah.
Yeah, that's the paper path, Huxley.
Yeah.
Because how do you make up different colours? What primary colours do you need?
Red, blue, and yellow.
Oh, that's for an RGB. This one,
Yellow!
printers are slightly yellow. Correct, Huxley. Yes, printers are slightly different. They have yellow, cyan, magenta, and black. And you can make it up with RGB, but this is how printers work. You get more deeper colours and
Yellow,
a better palette.
Cyan.
Yellow, cyan, magenta.
So that's yellow, that's cyan, that's magenta, and that's black.
Black. Yep. Cool, huh? How many parts do you think are in here, Sagan?
Let me... 1,000 or more.
1,000 or more parts. So yeah, this is what has to go into the design and manufacture of a simple laser printer.
One printer.
One printer, that's it. Travels up, that's where it always gets jammed. Is that funny, Huxley? Paper jams. Nothing worse than a paper jam, is there, Huxley?
Well,
No?
let's see. What's worse than a paper jam? How about falling off a cliff, getting sucked into a black hole? Worse than a paper jam. And also falling down a big waterfall and a lava fall.
What we got here is, looks like we've got some sort of sensor happening. Not sure what they are. Looks like they just pop out. That's nice. And then you just snake. Brilliant. Scratch that, unfortunately. That's just a contact. That just makes contact. That's the toner sensor contacts. There's nothing doing there at all. Toss. If you have a look down in here, look, this looks for all the world. There's wires going in there, and these look like some sort of lead that emits into drum. So what's that trying to sense? I don't know. So where that's actually going is through, there's a little light pipe, and that goes into all this, which goes right along the drum. Is it a LED or is it actually a photodiode? It could be a photodiode just to detect that they're actually lighting up, I guess. Okay, so what you got here is this plastic holder, which goes the whole length of that drum, and then you got this light pipe. Physically feel those little marks in there. Those little marks go all the way along. Why? I mean, that's not how the drum is imaged, so I don't know what the deal is there. That's weird. If you want to know how the drum is imaged, well, actually look inside there. Look at all the colour. That looks like a Ken Doan painting. It's absolutely remarkable. Anyway, the imaging actually comes through these bottom slots down here. There's glass plates in there, and that's the actual imaging engine. So there's actually, once you take those metal plates off, there's a big plastic tray over the top of all of this. So all your lasery goodness is going to be in there. And you'll notice that some of this is actually welded. See, I got some weld marks there, and down over here. So yeah, it's not just all screwed together. And if we take this side panel off here, we should find our high voltage stuff. Ta-da! Look at that. High voltage slot cutouts in the board, all in here. So that's all for the my Corona wires, and generates the high voltage, which then used to electrostatically cling. It's not high current, it's just high voltage to then electrostatically cling all of the toner to the drum. And there it is. That just folds out. It's really interesting in that they use these springs up here like this to actually connect through to the board. So you can see the link contacts down here on the PCB. Very simple. So they've got multiple channels there, and as I said, you can see all the high voltage isolation slots. Very nice. Single-sided construction, of course, to save cost. And it looks like we got a is that a tripler there? And then we got more channels down the bottom here, more spring contacts. Very cool. Wow, check it out. Looks like this whole assembly is just going to slide out. Ha ha! Bobby Dazzler. We've got some just clips on the end here, and I think, here we go. Yep, ta-da! There you go. There's our laser mechanism. Isn't that fantastic? Check this out. We've got 4 laser diode modules down there. They could have just done it with 1, but then you wouldn't get the high speed throughput, and then you'd have to have something that switched between the physical position of the 4 drums. Anyway, so they're going for 4 separate laser diodes here, and they come out, they emit out here, and you'll notice they're at different physical heights here, and so are these mirrors here. They're at 4 different physical heights as well. So the laser comes out there, bounces off there, and then they've got various other mirrors all in here, all doing the fantastic goodness. And then that's our scanning prism there, scanning mirror, whatever you want to call it, that raster scans all the way across like this. And then you just got various mirrors that bounce off to the various drums. Like this one here, this is actually mirrored on the underside there, for example. This one up here, we've got another mirror there. Yeah, I mean, follow the path. I won't do it for you, but yeah, you can work out that there's going to be 4 separate paths in there for the light to scan across. So one scans across 1 drum here, 2 drums, 3 drums, and then 4 drums like this. That's terrific. I like that. And they're just using the 1 rotating mirror down in there to do all the scanning. So they don't need 4 separate scanners. They just do it at slightly different heights so they don't interfere with each other. And then they just do their reflectory goodness onto the 4 separate drums. There's a lot of sweet engineering that goes into that. I mean, no really usable parts unless you had some novel application for the whole thing, the whole assembly like that. I don't know, you might be you could turn it into laser art or something like that if you're like a laser artist, or something. That'd be kind of cool. Are they visible? I don't know if they're actually visible, but you can definitely source 4 lasers in there. For those playing along at home, there's a laser diode board. I'm not sure if we can get a part number on those chippies. Might be able to in 4K resolution, I'm sure. And there's not really much else doing on the bottom side there, so I think we're pretty much done with salvaging this thing. So that is our total haul from this thing. Well, not the parts that we're going to keep. I'll show you all the good stuff we got, but that's basically the guts of it. Most of it, of course, you know, you throw out the whole chassis. It's absolutely useless, and all the plastic moldy bits and the trays and things like that. And, you know, you might be able to have fun with the laser mechanism. Otherwise, you salvage the lasers if you need an IR laser in the thing. Let's have a look at some individual stuff. Well, as for the main processor board, there's really nothing here you'd want to salvage. Maybe that looks like a little DC to DC converter there and there. Maybe you might want to suck those out. Perhaps are they through-hole jobbies? No, they're BGA. Oh, wow. That's amazing. Anyway, you might still be able to use those. Perhaps, you never know. Get the hot air gun on those, suck those out. Little DC to DC converter modules are always useful. Should always have a bin of those. But, you know, if you got the room, you might throw this in your bin of, like, just random boards or something like that. Who knows when you might need a little surface mount cap. These are, even if these are 10 years old, like, you know, it can still get you out of trouble. Oh, it's another little DC to DC converter module. Copyright 1984 to 2009 Adobe. It's got some of their secret screw postscript code in there, no doubt. What's an LED, or is that Q? Hard key, what's that? It's unpopulated. Anyway, yeah, like there's nothing else on there to salvage, really, so meh. But of course, one of the good things you get out of these are motors. In this case, little stepper motors. Mitsumi stepper motor for those playing along at home. 7.5 degree step, so, you know, not really high precision, but, you know, that'd be a real top quality stepper motor. So you'd put those in your stepper motor box, no doubt. And I said I'd show you this one closer up. Look at this. I mean, it's just absolutely amazing. Check that out. And inside here, they're like a helical spiral thing. So, absolutely fascinating that these individual cogs, they're, looks like they go, what, around and then snap back down? Is that, yep, they go once around. Well, this one goes once around like that and it could drop back down or something. So what that's actually doing, I don't know, but that's really impressive. And then, of course, you got this brushless DC motor on there, 24 volts, 2 amp jobby, no other markings. So, yeah, whether or not you want to salvage those, up to you. We got quite a few. I think there's like 3 or 4 of those. Oh, and by the way, with anything, be it a board, a motor, a sensor or whatever, anything you take out of these, keep the cable looms with them, because, you know, it might be impossible to get, or really pain in the ass, to get another one of these connectors. If you salvage the motor and then you want to go use it sometime, you have to hack it in, or you'd have to solder the wires in, or replace the connector or whatever, because you wouldn't have that sort of thing in stock. And here's one of those stepper motor boards. Another tip, of course, because this screwed into a metal plate, if you want to go reuse this thing, just keep the screws. Screw them back in there so that you've always got them to hand. Anyway, brushless DC motor controller. Have no idea what that chippy is there. It's unmarked. It's got a heatsink pad on top, which I don't think was connected to anything, but anyway, yeah, if you can figure out how to reuse that, no wuckers. And you should, of course, have a fan junk bin as well. And this one, Nidec Ultra Flow, that looks really nice. Made in Vietnam. I don't want my Vietnamese viewers, but that's a nice little profile, low profile fan. And I think that's probably going to be like really super silent too. So I could definitely salvage that. You know, you could turn something like that into a little, not fume extractor, but a little soldering fume blower, just to blow across your bench, just to get the fumes out of your face. And something like this LCD panel, I wouldn't even bother keeping that really, unless you got the unless you collect LCDs. Maybe you should have a bin of them, but yeah, generally you're going to choose a more specific one for a project. But you know, it could be useful. So if you want to salvage the LCD, I mean, I wouldn't keep the whole thing. I'd get the LCD out of that and just salvage that. One nice thing you can get out of products like this, IEC connectors, very nice. But this one check this out. That's a score. That's an earth leakage circuit breaker, ELCB. So, upside down, all the electrons are going to fall out. There it is. What is that? That's a 10 milliamp jobby. Wow, that's actually quite low. 10 milliamps, Fuji Electric. Wow, that's a keeper. Fantastic. It's got the test reset button on there. Beauty. Another digital board. Check this out, Fuji Xerox. Hello, Dell, who's making your printers for you. We've got big single inline package. Are they motor drivers or something or other? Anyway, yeah, but apart from that, that'd be like an E² prom, is it? It's in a socket. Yeah, like there's nothing. You wouldn't really keep that. You might have use for, as I said, like a box of miscellaneous teardown boards and stuff. Useful because you might need a crystal out of it or something like that. Now, the My Corona board, unfortunately, the bad thing about keeping these is that they're big and they waste, a lot of space for, not many parts. But, you can salvage like little heat sinks. Have we got, are they regulators or switching trannies down in there? So, yep, you might be able to salvage those little transformers, electrolytic caps and stuff like that. But, yeah, the physical side of that, like the parts reward versus the storage space for something like that, unfortunately, is not great. And it's just got SMD stuff on the bottom you wouldn't care about. And I thought those might have been MOS, but they're high voltage caps, are they? I can't read those there. But, oh, look, little trannies. Check them out. Tiny little 3-pin, single inline, square package trannies. Wow, you just don't see those these days. But of course, the piece de resistance of tearing down products like these, the power supplies. You can just get a ton of stuff out of these. Of course, you ditch the metal work. You don't want to keep that. It just takes up space in your bin. But you can get top quality, like electrolytic caps. Yep, Nippon Chemicon, thank you very much. None of that one hung low rubbish. What are these? Yep, more Nippon Chemicon down there. You got big ass chokes. Nice little surface mount fuses down in there. Check those out. Look, you got some real top quality relays there. Awesome. Oh, and check out that transformer. That's just pornographic. I'm not sure if you'd be able to reuse that, but it is beautiful. Thing of beauty. Look at it. Oh, wow. And over here, are they some big-ass mobs? What are they? Wow, they're enormous. Yeah, just more chokes and big X and Y class caps and things like that you can get from these. Opto couplers, some beefy switching trannies there by the looks of it. Fantastic. Toshibas, none of that one hung low rubbish. And what kind of relay have they got down in there? I think it's a relay. Wow. So, yep, just generally lots of parts to salvage out of a top quality power supply like this, designed for high MTBF, mean time between failures. And yeah, that's, it's Panasonic. Panasonic. Looks like they designed this. Wow, there you go. Panasonic designed power supply. Beautiful.
Beautiful.
So there you go, that's what's inside a laser printer. Probably not as many goodies as a photocopier perhaps, but considering that more people throw out these things, then yeah, there's definitely some salvageable parts in here. Not a huge amount, but power supplies, motors and IEC filters and other goodness, they're definitely worth scrapping. So anyway, I hope you liked that. If you did, please give it a big thumbs up, and as always, discuss down below, and you can check me out on my library channel as well, and that's over on EEVblog.tv. Hope you enjoyed it. Catch you next time.